Alrighty here. So on page 115, you'll see that we are going to be looking at sequences of transformations. Okay? Or in other words, what happens when you apply more than one transformation to a particular figure. Okay? Again, in this little explore here, it asks us to use some geometry software to do particular transformations, but we'll kind of do this on our own without using the geometry software, because I think we should be okay without. I don't think it really requires geometry software to do this stuff. We can just kind of like use our imaginations, and I think it should be fine. So we can think of a transformation as being a function that takes points on the plane and maps them to other points on the plane. Transformations can be applied one after the other in a sequence where you use the image of the first transformation as the pre-image for the next transformation. Okay? So we're going to be asked to do this here. So for letter A here, where it says, asked us to use geometry software to draw a triangle and label the vertices A, B, C, then draw a point outside the triangle, label it P. Okay, this is setting us up for a rotation. It's going to have us rotate triangle ABC 30 degrees around point P, so that's going to be counterclockwise, obviously. Label the image as triangle A prime, B prime, C prime, because it was transformed. Then we're going to rotate, then it asks us to rotate triangle A prime, B prime, C prime 45 degrees around point P, and label that image as triangle A prime prime, B prime prime, C prime prime, right? Because it is transformed twice, once from A prime, B prime, C prime, and then again from the ABC, and sketch that result. Okay? So the question for letter B that we want to be able to answer is, if we take triangle ABC, rotate it 30 degrees around point P, and then take that image and rotate it another 45 degrees around point P, what single rotation could we have done there to go from our very first triangle ABC to then the very final triangle A prime prime, B prime prime, C prime prime? So go ahead. What do you say, Brandon? 75 degrees. How did you get that? What did you do? Exactly right. Yeah. The 30 degrees from the first transformation. What's up, Grace? Short a protractor. For me or for someone else? Okay. Well, maybe we'll get some people to share, and then we'll just do it that way. Okay. So 30 degrees from the first transformation plus 45 degrees from that second transformation. Results in 75 degrees total there. Okay, 75 degrees total, right. Okay. Now, this one here is a little bit more interesting. So I think I'm going to actually have us do this. I'm going to have us do this using the mirrors, I think. So here's what we'll do. Grace, if you want to mind passing out one of these, I know I didn't ask you to. Like, this might be a good idea to do this. So Grace is going to come around and give you guys all mirrors. Okay, and we'll actually do this in this little white space that we have here. So what I'll do is draw a pair of intersecting lines. Like so. And then I'll draw a triangle DEF. Draw like a small triangle here. Let's see. I don't want to make it too crazy though. Okay, and I would suggest that you try to draw it similar to mine, just because otherwise it might not fit. You might go off the screen and stuff like that. So it'll be helpful if you try and draw it similar to what I've got. Okay, and let's reflect it over. we'll call this line right here, we'll call this line the line J. And then we'll call this line right here, we'll call that line K. So there's J and K. And the directions ask us to reflect triangle DEF across line J first, label that image as D prime, E prime, F prime, and then we'll reflect it across line K and label that image D prime prime, E prime prime, F prime prime. Okay, so go ahead and do that once you've got your paper there. I'm going to do it too here. Let's see, this is going to be a little bit tricky. I'll just go this way. If you need to turn your book or something like that, feel free to do that too. Especially if you're right-handed and like I am. And again, once you reflect DEF over line J and you have D prime, E prime, F prime, we're only reflecting D prime, E prime, F prime over line K. Don't also reflect DEF. So only reflect D prime, E prime, F prime over K. Okay, only reflect the D prime, E prime, F prime over K. Don't reflect the whole thing. Oops, and don't forget, for the last, that second reflection, you should put double primes there for it. Do that kind of double reflection there. Double reflection through those intersecting lines. Something looks kind of like that. So once you've got that double reflection there, okay, we're going to ask a very similar question to what we did before, right? Before, in letter A, we asked Brandon answered for us, sorry, that rather than doing two rotations about that same point P, we could just combine the two rotations together, right, the 30 degrees and the 45 degrees, and get a single transformation and just do a single rotation of 75 degrees, right? Here, we're doing a double reflection over the line J and K. Is there a single transformation that we could use to take triangle DEF to triangle D prime prime, E prime prime, F prime prime? Olivia, what do you say? A rotation. Yes. Now, you say 180 degrees. How did you determine the angle here for this? Just kind of looking at it and seeing like it looks like about 180 degrees. Okay. There is a relationship here, but in my case, it's not going to be 180 degrees. It has to do with the angle between K and J. Okay? So, but yes, exactly right. There is a rotation. So a single transformation that would map triangle DF to triangle D prime prime, E prime prime, F prime prime, it would be a rotation. By the way, Avery, where would that center of rotation be?
Where the lines intersect.
Exactly right. Our intersection point of the two lines is our center rotation. right. So the next step asks us to then repeat step A using other angle measures and then make a conjecture about what single transformation will describe a sequence of two rotations. So again, we kind of figured that out, right? If you have two rotations about the same center, you can just add those two rotations together, and that'll get you your overall rotation, okay? Same thing if you have three rotations, you can just combine those all together. So 1 and 2, similar questions. Step 3 also asks an interesting question. It says, it has us repeat step C, but to make lines J and K parallel instead of intersecting. So let's think about that. If K and J, instead of intersecting, were parallel to one another, what transformation do you think would result after doing a double reflection over parallel lines? What do you want to say there, Madison? Make the same image. So what single transformation would that result in? It would be the same image, yeah. Right, but so a double reflection over parallel lines would be the same as what single transformation though? Yeah, okay, you think it's a 180-degree rotation? Okay, what's that? 360-degree rotation? Okay, maybe. What do you say, Avery?
Translation.
A translation? Okay. So I'm not going to say what the right answer is here. I'm going to have us maybe look at that later once we're done talking about this, okay, using our computers, okay, using the geometry software and stuff like that too, okay. And also there is a relationship here where you can use to figure out what the angle of rotation will be as well, very specifically. But again, I'm not going to tell you what that is just yet. I'm going to try and have you guys figure that out for yourselves. Okay? All right. So let's take a look here then on the next page, page 116, at the explain one. Okay, kind of like the meat of what we really want to be able to do here today. We're going to do like part of this section, but we're not going to do the whole thing. So I think we'll probably go up to, yeah, that's what we'll do. Yeah, okay. So for number one, explain one here. Okay, so in the Explorer, you saw that sometimes you can use a single transformation to describe the result of applying a sequence of two transformations. Now you will apply sequences of rigid transformations that cannot be described by a single transformation. Okay? So for example here, letter A asks us to reflect over line L. So we're going to reflect triangle ABC over line L, then translate along vector V. Okay? And they kind of do that for us here, so we really don't need to, do it, I guess. So remember, to reflect triangle ABC here, you could try and count the squares, although I think that's going to be a little bit tricky here with the way it's set up. So instead you could use your mirror, or you could use your patty paper to reflect this. Okay? Either way, it's going to reflect to right there. Right? And they're going to translate using that vector V. Okay? And how is this vector V telling us to translate here? In which direction and by how much? How would we translate triangle A prime, B prime, C prime using that vector V? What does it tell us to do, or how is it telling us to go here? Say it again there.
Slope of 1/4.
Okay, slope of 1/4. So that means we're going to go which direction, how much? Right 4, and then up 1. So you're going to take each point here, C prime, B prime, and A prime. Each one you're going to move right 4 and up 1 to get your A prime, prime, B prime, prime, C prime, prime. Okay? What if we reversed these directions? What if we said, instead of reflecting over line L and then translating along vector V, what if we translated along vector V, then reflect over line L? Would that result in the same location of A prime prime, B prime prime, C prime prime? Yes? Well, why don't you guys go try it? Use your space right here. Translate triangle ABC along the vector V, and then reflect it over line L. See if you get the same result or not. Okay, so go ahead, translate and rotate, or sorry, translate and rotate, translate and reflect, and see if you get the same result or not. Okay, go ahead and do that. I'll do it in red on that space as well. Okay. You might have to extend your grid a little bit. Oops. Ooh, me doing this in red was a bad idea. I won't be able to see it with my mirror. Someone's whistling the Mario theme song. Okay. Make sure everyone's translating. Okay, so in general, sorry, if we change the order here, if we change the order of our transformations in the sequence, do we end up in the same place? No, we don't. Okay, no, we do not. Right? Kind of compare and contrast here. Okay, A prime prime, B prime prime, C prime prime ends up here with the red order of sequence of transformations. And then in the original sequence, which is just the reverse, we end up right there. So you can see it's not the exact same thing. Okay? So, you guys remember if there's, I guess this is like the commutative property, right? The commutative property says that if A plus B is the same thing as B plus A, right? Or A times B is the same thing as B times A. The commutative property does not apply here to sequences of transformations, or at least mixing reflections and translations together. It doesn't necessarily apply. Okay? All right. So let's go ahead and have you try there. Let's do letter B. Okay, so go ahead and try letter B. So this is a 180-degree rotation around point P, then a translation along vector V, then a reflection across line L. Okay, so go ahead and give that one a try there. Okay, I'll work through it up here for those of you that maybe want some extra help or stuff like that. Okay, remember to do a 180-degree rotation around point P. We want to take our triangle here and connect P to C. So, and Emma, this is maybe for you too. I don't know if you since you weren't here yesterday for the rotations. So to do this rotation, we take our shape and we connect it to point P. I'm going to connect C to P. So I'm going to, even though it's like already there, I'm just going to like darken that in. Okay. Ordinarily use a straight edge, but we have the straight line there, so we can just do it that way. Okay, then you'll take your protractor and place its center on point P. Okay, and then measure a 180-degree angle. But of course, measuring a 180-degree angle is pretty easy because it's just the opposite direction, of the thing. So it's already drawn for us. So really, there's our 180-degree angle right there. So, it's like, there it is kind of thing. Now, granted, I'm going clockwise there, so maybe I should have drawn it this way. since we're not given a direction which way to rotate, it's assumed to be counterclockwise. But again, since it's 180 degrees, it's going to end up in the same spot as it would have clockwise or counterclockwise. Okay? So we have our initial side. We have the angle of rotation. It's going to go out this way. And so now we're going to take patty paper, okay, and then you're going to trace the point P and the vertices C, B, and A. Okay, if you want to label them, you can. And then also make that same connection from P to C that we drew in there, too. Okay, so you should have something like this in your patty paper. It should look like that, and that's point P right there. Got it traced okay there? And so now what we're going to do is rotate at 180 degrees. So we're just going to take point P, keep point P on your patty paper on top of the point P on your grid there, and rotate 180 degrees. And so there it is, rotate 100 degrees. Point P is still on point P, and there's where your 3 points are going to be. 1, 2, 3, right there. Okay? But unfortunately, there's no way for us to transfer these points with what we've got, right? All the writing is on this side of the patty paper, and we don't have any writing on the back. So what you want to do is then flip your patty paper over on your desk, draw on the backs of the A, B, and C points. Okay, and then again, realign things here, and then do that rotation. And now when you draw on the fronts of the points, that should transfer from the backs onto their locations. And so there they are, right there, and right there. Okay, and of course we're going to label them. That one's C prime. This point right here will be A prime. And this point right here will be B prime. Okay, and then connect the dots to get your shape rotated there. Okay. Did you get that rotation done okay, Emma? Okay. And so now you should be able to do the rest. Translate along vector V and then reflect across line L. Okay, so go ahead and do that here, and I'll do it as well. You don't need to use your mirror here, really, right, to do that reflection. It's pretty easy to just count since it's a nice horizontal line. So don't feel like you need to use your mirror if you don't want to. Okay. Questions on any of that? Yeah, Madison.
It was actually for that here.
Oh, the previous one? Okay, yeah.
Just wondering, if you reflected it over A, wouldn't that mean you would make it the same image? Would that work for
Like for
everything,
this
or
shape
just
you're
this
saying,
one?
for the original ABC, if we reflected over line L,
Instead of line L, if you reflected it over point A.
see, that's a good question.
Would that work for everyone, or is it just that one?
Reflecting over point A is an interesting proposition to me.
Because like you just that's basically what you did the first time, and then
It does, like if, well, my argument would be, I think that like if because again, I don't know if there is such a thing as reflecting over a point, but if there were, I would agree that like B prime would be the reflection of B over the point A, but I don't think C prime would be the reflection of C over point A. I think C, if I were thinking about reflecting C over point A, I would think C would be going like to here. Like if you think about reflecting C across point A, right? It's like up 1, left 3. So I would want to go another up 1, left 3, and take it to this point right here. So create something like this almost instead. Do you see what I'm saying there? Like reflecting C over point A, I would want it to be equidistant, because again, a reflection should be like equidistant from that point or center line of reflection. So I would want it to be there. It would still result in a congruent, same image, but this is more like this is definitely over the line L, because it's again equidistant from that line L there.
Okay.
But again, I don't know if reflecting over a point is a thing or not. But it looks like it would actually kind of like work in this scenario at least. So what's that?
If you did it like the other way,
Yeah.
then it would work if you flipped the reflection translation.
Right, exactly. Then it would not work there for sure, because it's like farther away from the point there. Or farther away from the line of reflection. Okay. Yeah. So there's our final image. Again, make sure that you had 3 primes. So A prime prime prime, B prime prime prime, C prime prime prime. Okay? In those images. All right. Number 4, are the images you drew for each example the same size and shape as the given pre-image? What do you say? Are the images you drew for each example the same size and same shape as the given pre-image? Yes. Right? In what ways do rigid transformations change the pre-image? What do you think about that? Yeah, Daniel?
It changes placement.
Placement. Okay. You could also say like orientation if you wanted to, like the order of points. Okay, right? Because here, for example, when we when we reflect, reflection changes the orientation, right? If you go clockwise around the shape, you go A prime prime, B prime prime, C prime prime. But if I start back at A here in the reflection and go clockwise around the shape, it goes A prime prime prime, A prime prime prime, B, C prime prime prime, then B prime prime prime. So orientation changes, okay? So there are some kind of changes, but not like really significant ones like the size or the shape, right? Number 5, we already know the answer to that, so we can skip it, right? We know that the order does make a difference in most cases. Sometimes it doesn't, okay? Sometimes it won't make a difference. For part B, describe a sequence of transformations that will take A prime prime, B prime prime, C prime prime back to the original image, okay? So what are your thoughts here? How can we maybe take our final image here and get it back to this position originally? Yes, Avery, what do you say?
A reflection over line L, and then translation over a vector that goes down 1 and left 5, so it's like negative.
Okay, I see what you're saying.
And then a rotation 180 degrees about point P.
Okay, so essentially just undo everything we just did. Exactly right. That's one thing we could do, is just go backwards from everything that we just did. Okay? Can anyone come up with a different set of transformations we could use to get from here to here? Any ideas? You can use your own vectors if you want. You can use your own lines of reflection if you want. Madison, did you have an idea? No? Okay. Here's a thought, right? What if we drew a vertical line in and reflected this shape over this vertical line? I don't know, I'll call it like M. Oops, I can't draw M's. There we go. All right, if we reflected this over line M, it would then look something like this. And again, I can draw that M anywhere, so I drew the M specifically so it goes through point A, so it kind of stay put, and that would put B right there.
Prime prime, not prime prime.
It would be what?
Wouldn't you reflect prime prime, not prime prime?
Well, I see what you're saying. I could reflect this one. I'm going to reflect the final one here, though. And so that would result in something that looks like this. Okay, so I've got this shape. And now to get this shape back to the original position, what do I need to do now? What kind of transformation? To go from here to here, what do we need to do? Yeah, it's a translation. Yeah, go left 1, 2, 3, and up 1. Left 3, up 1. That would get us back to our original shape. Okay? So absolutely, doing all the previous transformations in reverse would get us back to the original, but sometimes you can do it other ways too. Okay? So one option, do the opposite of the 3 transformations in reverse order. That's essentially what Avery was having us do, right? 2, reflect over line M and translate using, I'm going to put the vector in component form. What was it? -3, 1. And then 3, there's many others, right? You could do an infinite number of combinations there, but those are at least 2. All right, questions on any of that? All right, we're going to stop there. We'll do the coordinate stuff more tomorrow. For right now, that's all they gave was coordinate stuff here. All right, what I would like us to do then. All right, I'm going to have you guys, for your homework, on page 122, okay, I would like you to do number 1. Four, 7, and then 9, 10, 11, and 12. 9 through 12. Okay, so 1, 4, 7, 9 through 12, starting on page 122. Okay. Short assignment there. Okay, I tried to keep it pretty minimal on the rotation stuff, just so that way you wouldn't necessarily need to have a protractor at home. 180-degree rotation is pretty easy to do without the protractor and stuff. Okay. 7, keep in mind you are predicting the result, like where it will end up, roughly where it will end up. Okay, but of course you can just do it too if you really wanted to. And then 9, 10, 11, and 12, you're matching letters there. Okay. Of course, at this time, if you would prefer to try and take a look at that TenMarks assignment, feel free to do that. Okay, that's fine. So again, feel free to take a look at that TenMarks assignment right now if you'd like, instead of doing the homework for the book there. That would be a fine thing to do too, and I'll be happy to come around and help with anything right now that you're working on. Okay. So, Jenny, question. Let me get this video stopped real quick, and then I'll come right there.